Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Sagitta Speakeasy by Katie Splendor. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We also have 9 green squares form an extra region containing the digits 1 to 9, so there are no repeats amongst the digits in the green squares. We also have modular lines, where any set of 3 digits along hollow teal modular lines must contain a digit from each of the following sets, which is 147, which are the digits on the left side of your keyboard, if you have a numeric keyboard also. 258, which are the digits in the center column of your numeric keyboard, and 369, which are the digits on the right side of your numeric keyboard. Also, they are known as a modular line because if you take if you divide all those numbers by 3, they will divide into modulo sets. 147 are all 1 modulo 3. 258 are all 2 modulo 3, and 369 are 0 modulo 3, right? If you divide 3 by 3, you get 0 remainder. And that's what modulo means. We also have XV sums, where digits separated by an X sum to 10. And okay, so right, to continue on the modular lines, let's do that. Any 3 consecutive digits on the modular line must contain a digit from every set of 1 modulo 3, 2 modulo 3, and 0 modulo 3. So this could be something like 6, 2, and 7. That would be valid because you have in this set of 3 consecutive digits, a digit from 0 modulo 3, a digit from 2 modulo 3, and a digit from 1 modulo 3. For XV sums, digits separated by an X sum to 10, and digits separated by a V sum to 5, and there is no negative constraint. So, for example, if this were, say, a 4, this would have to be a 6 because these 2 digits must add up to 10. If this were, say, a 2, this would have to be a 3 because these 2 digits must add up to 5. And that's an example of how X and V's works. And finally, we have Kropki dots, where digits separated by a black Kropki dot have a ratio of 1 to 2, or 2 to 1. Digits separated by a white Kropki dot are consecutive, and there is no negative constraint. So, basically, if, for example, this were a 2, this would have to be a 1 or a 4 to maintain the 1 to 2 ratio between them. If, for example, this was a 6, this would have to be a 5 or a 7 for these digits to remain consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the first thing that I see is for these squares, again, which have no repeats, 4 of them are next to V clues, or V clues. That means they add up with the neighboring cell to add up to 5. So it must be 1 through 4 in those cells. Well, since there are no repeats in any of the green cells, that means these must be 1 through 4 here. We can also match these as 1 through 4 also. So these are 1 through 4, and these are 1 through 4. Now the thing is then that the other remaining green cells or green squares must be 5 through 9 because we have 4 cells in the green squares which must contain different digits, and they are all containing digits from 1 through 4. So these must be 5 through 9. Okay, so on a modular line, or actually any line where you have three consecutive consecutive digits must be from different sets, three different sets. You'll always know that this every third digit, every third cell on the modular line must be from the same set. And you know that specifically because what happens if you have these three digits? Well, you randomly assign a set for both of these. So we're going to make this orange and this yellow. And we'll make this pink. Well, for these, we know these are three different sets, right? For these three cells, what are the sets possible? Well, we still contain the yellow and the orange set, which are two different sets, but we lost the pink one. So we need another pink to make this essentially fulfill the three consecutive cells must contain digits from three different sets. So this must be pink then because of that. So these are the same set. This is yellow because it's also the same set. We lose yellow in these three cells, right? So we have to have another cell, another digit from yellow. So that must be yellow. We lose an orange here, so we must gain an orange for this set of three consecutive digits, etc., etc. So this is pink, this is yellow, this is orange. So we have similar scenarios here. Now the thing is, these cannot be pink. Because they are the same set, right? Because of the same modular, the way that three digits work on a modular line, or any line that must contain one of three distinct sets. You always have the third digit, or every third digit on those lines must be the same set as another every third line there. Therefore, these two are the same set, same modularity, but if these are the same modularity, these must be a different modularity. We don't know which though. But the only ones with the same modularity or same modular remainder for 5 through 9, 5 and 8 have the same modulo because if you divide 5 and 8 by 3, you get 2 as a remainder, and 6 and 9 have the same remainder. So this must be either 5, 8 or 6, 9 to be the same set. That means this is a 7 here because we have a 5, 6, 8, 9 quadruple in the green square sets. So these must be essentially that set. So this is 7. These are different modulo sets, and these are different modulo sets. What else do we know from this? These are in 1 to 2 ratios. That doesn't tell us too much. We know it's non-5 and 9, because 5, if you have 5, you get 2.5, which is not a normal Sudoku digit, which is not a digit. And if you double 5 or 9, you get, so if you have 5 or 9, you get 2.5 or 4.5 respectively, which are not digits. And if you double 5 and 9, you get 10 and 18, which are not digits. That's the reason why they can't be next to the black crop key dots here. The yellows are here. Okay. Yeah, let's do that. These two digits must be a different set of the V's than these two digits. And the reason why is these two add up to 5, so neither of them can be that digit there. But if this adds up to 5 with another digit, it cannot be this pair, right? So say this was 2 and 3. 2 and 3 couldn't be here, so that's 1 and 4 here. And this digit must also be 1 and 4 to add up to 5 with the 1 and 4 that's here. So that means this cell sees all the different possibilities for 1 through 4. And the reason why we know that is these two are from one set that adds up to 5. These two are from the other set that adds up to 5. And these two are in the same row as this cell, and these two are in the same box as this cell. So this cannot be 1 through 4. This must be 6 through 9 here, which makes this 1 through 4. That means we have a 1, 2, 3, 4 quadruplet in row 2, which eliminates 1 through 4 in the rest of the row. So this must be, this has to be 6 through 9 to add up with 1, 2, 3, 4 to add up to 10. This must be also 6 through 9. This has to be 5 through 9 here, 5 through 9 here, 5 through 9 here, but this can't be 7, and 5 through 9 here. Okay. This, I guess we'll do light, medium, and dark. This will be medium gray. I guess we'll have this as light, and these will both be dark. And dark cannot be the same as pink, but we don't know which one it is. This will be medium because we lose a medium for this set of 3 digits. For this set of 3 digits, this has to be light. This is dark again. So this is dark. This is medium. This is light. Okay. So these 3 match, and these 3 match. That's interesting. The only ones that match then, these are 2 mod 3 or 0 mod 3 here. The low digits that are 2 mod 3 or 0 mod 3 are specifically 2 and 3. There's no other possible combination. Therefore, this must be a 2 or 3. Right? Because 5 and 8 are both 2 mod 3, so they would force this to be a 2 if this is 5 and 8. If this is 6 and 9, that's 0 mod 3, that would force this to be the same modulo, so this would have to be 0 mod 3, which is a 3. So these are specifically 2 and 3, which must add with 2 and 3 to add up to 5. So this is a 2, 3, 2, 3 pair here. That leaves these digits as not 2, 3, and these digits as not 2, 3. So this is a 1, 4 pair here. This cannot be 1 or 4 because we have a 1, 4 pair in the column. So this, and it can't be 2 and 8 or 3 and 7 because we have a 2, 3 pair in the box. So this must be 1, 4 with 6 or 9 here. That means this is not 6 or 9, 7 or 8 to add with the 2 and 3 to add up to 10. Same with this one. This can't be 2 or 3. This must be 1, 4 with 6 or 9 here. Okay. What does that mean? That means in this center box, again, the dark is either 2 mod 3 or 0 mod 3. Same with the pink. That means the 1 mod 3 must be one of these two sets, right? Because this can't be the 1 mod 3. And we need for every three cells on the modular line to essentially have one from every set. So this must have one of the 1 mod 3s. This must have one of the 1 mod 3s, which means 1 and 4 must be in one of these 4 cells in the central cell. Because we already have a 7 here, right? What does that tell us? I'm not really sure. This is a different modulo than this cell because they're consecutive. Same with this one. So this cannot be yellow. This is orange or pink. We're not sure which. This is dark or or light, actually. It can't be medium. Medium's here. Um, okay. In this upper left-hand box, where is the other 1-4? It cannot be here because of the 1-4 pair in the row. Obviously, these are already filled out, so is this, and it cannot be here because of the 1-4 pair in the column. So this must be a 1 or 4 here. Okay. Um, these must be of different modularities, right? Because they are on they're consecutive digits on the modular line, so they have to be different sets. And if it were 2 and 8, they would be from the same set. So this must be a 3. So this is 3, which makes this 7. So the light digits are the 1 modulo 3. So let's remove that one then. So the light digits are essentially the 1 modulo 3s. We're going to make those green. So this cannot be, again, cannot be 5, 6, 8, or 9, so this has to be a 7 here. That makes this a 2. So the mediums are, so we're going to make the 1 modulo 3s green. So this is green. The 2 modulo 3s have to be the medium grays. And the darks we're going to make those blue. Sorry, the 0 modulo 3s we're going to make blue. So this must be a 6-9 pair. Again, because these have to be different digits, so this cannot be 3, it has to be 6 or 9. The medium grays, I don't know. I guess we'll make that pink. And pinks obviously cannot be 0 modular 3 because we have the 6-9 pair. This must be 6-8. Sorry, 5-8. So actually, yeah, so that works for pink. So this is pink. These are pink. So all the pinks must be 2 modulo 3. So this is 2. This is 3. That means the yellow matches the blues. So we're going to make the yellows be the blues. And the orange must match the greens then. So this is 2 and 3. This has to be a 5-8 pair. This can't be 1 or 4. This is 1 or 4 then here. And this is 1 or 4 here. Because these are the 1 modulo 3 on those lines. 1 and 4 have to be in a 1-2 ratio. 1 has to be in a 1-2 ratio with 2. Therefore, 4 has to be in a 1-2 ratio with 8. Because we already have a 2 in that row then. So this must be a 2-8 pair. Therefore, both of these are the 2 modulo 3s sets. This must be an 8. This can't be 7 anymore. This can't be 7 anymore. These are 2, 5, and 8. This is a 3, 6, or 9 here. Since this is a pink and this is a pink, this must be pink and this must be pink. So this is pink, this is pink. This is consecutive with blue, so it can't be a blue. It can't be the same set for blue. And it can't be pink because we already have a pink next to it on this modular line, so this must be green. So this is green, which forces this to be green. This is blue. These are actually both green because they're 1 of 4 pair. So this is green, this is green, this is green. 6 or 9 has to be the blue modular. So this is 6 or 9. This is blue. This is blue. This is green. And we have green here. Okay. Therefore, this is 1 or 4. This is 1, 4, or 7. It cannot be 1 or 4 because of the 1, 4 pair in the column, so this must be a 7. This is 1, 4, or 7. That's fine. This is 1, 4, or 7. This becomes 3, 6, 9, 3, 6, 9. And these are 2, 5, 8. 2, 5, 8, 2, 5, 8. Okay. This is also pink. But let's remove those colorings because those aren't necessarily useful. Let's remove the greens and blues and let's start marking the 1, 4 pairs, right? We're going to mark this dark and red. These must be different numbers, so this must be the red, which makes this dark. This can't be dark, so this is red, which makes this a dark. This also must be dark too. So, where's the red in row 8? Cannot be here because of the red in the box. These are all filled out. So the red has to be here, which makes this dark. Where is the red in column 3? Can't be here because of the red in the box. Can't be here because of the red in the box. These are different sets, so they can't be 1 or 4. Therefore, it must be here. So this is red, guaranteed. Dark has to be one of these two. We're not sure which. Red is going to be one of these two. The rest of row 5 has to be 3, 5, 6, and 9 because of the 1, 4 and the 2, 8 pairs in the rows already. This can't be 3, obviously, because the 3 in the column. Let's see. The rest of row 8 is 1, 4, 5, 6, 9. And this can't be 1, 4 because of the 1, 4 pair in the box. So obviously one of these is 1, 4. Ah, where is the dark 1, 4 in the central box? Or actually in column 4. Cannot be here because of the dark 1, 4 in the box. Can't be here. And it can't be either of these because of the 1, 4 pair in the middle box. So this must be dark, and this must be red. Where is the red 1, 4 in row 3? Can't be here because of the red 1, 4 in the box. Same for this. This is not the same set. This is not the same set, so it must be here. So this must be the red 1, 4. That means this is 1 modulo 3 because, again, for every 3 cells, you will now change to the same set, right? So this must be the same set as this, and this is 1, 4, or 7. This must then be 3, 6, or 9. It cannot be 3 because of the 3 in the column. We have a 6, 9, 6, 9 pair in this upper right-hand box, which eliminates 6 and 9 from the rest of the box. This can't be 6 or 9, it's 5 or 8. Let's see. Okay, so this cannot be the red 1, 4. So it cannot be 1, 4 here, which means where is the red 1, 4 in row 8? It must be here. So this is red 1, 4. Let's see. That means red 1, 4 is one of those two. Red 1, 4 has to be one of those two, so it's kind of limited there. What about dark 1, 4? Dark 1, 4 cannot be here. So in this left central box, dark 1, 4 cannot be here, here, or here, and this is a different set than 1 modulo 3, so it can't be here. So this must be the dark 1, 4 here. That means, where are the red and dark 1, 4s in row 4? Can't be here because of the 1, 4 pair in the box. Can't be here because of the 1, 4 pair in the box. And can't be here because of the 1, 4 pair in the column. So the dark and the red 1, 4 have to be these two cells, which means this can't be 7. This is also 1, 4 then. We don't know which one's which. Okay. 1 and 4 of those, the only digit that these are consecutive with is this must be 4 and this must be 3, right? 1 cannot be consecutive with anything but 2, but this can't be 2. So this is 4 and 3. That means this is 1, and that must be 2 then, to be consecutive with it. So this can't be 2. We have in column 5, the rest of the digits are 5, 6, 8, 9. That's fine. That means the dark digits are all 4s. So the darks are 4s, and the reds must be 1s. So the reds are 1. We don't know which ones these are, so we can stop coloring the darks, because that serves its purpose. We could probably start coloring 6, 9 pairs, though. Okay, well, this is 6, then, because it has to be next to a 4 to add up to 10. This is 6. This cannot be 6 here or 6 here. This is 1 and 9, so this can't be 9 here. 9 cannot be here either or here. So this becomes a 5, 8, 5, 8 pair in row 2, which eliminates 5 and 8 in the rest of the row. This can't be 5 or 8, so this is 9. That eliminates 9 from being here, so this is 6. This has to be a different digit than this because there are no repeats in the green squares. So this is 9. That means this can't be 9, and this can't be 9, and this can't be 9. Well, in row 8, where is the 9? It must be that cell. So that's 9. This can't be 9 either. We know one of these two digits is a 9. We're not sure which. This can't be 9 either. This 6 eliminates 6 here, so this is 9. Okay, so where is the 9 in row 7? It cannot be here because of the 9 in the box. Can't be here because these are 2 modulo 3s on the line. Can't be here because of the 9 in the column. Can't be here because this is 1 modulo 3 on the line, so this must be a 9 here, which means this cannot be 9, which forces this to be a 9 here. Actually, yes, because there's no other place in row 5 that can have a 9. This cannot be 9. This can't be 3, then. This must be a 6. Okay, what else do we have? This can't be 4 because of the 4 in the row. This is 4. 1 is only in a 1 to 2 ratio with 2 out of 2 or 8, or just in general. So this is 2, and this must be 8. This 8 eliminates 8 here, so that's a 5. This 5 eliminates 5 here and here, so this is 6 and this is 3. This can't be 3 or 6, so that's a 5, which means that can't be 5, so that's 8. This is an 8, so this must be, and then there are no repeats, so this must be a 5 then, which means this can't be 5. This can't be 5, so it's 6. And this can't be 5 or 6, so it's 8, which makes this a 5. Again, this can't be 5, so it's 2 or 8 here. This is 1 or 4. These are all fine. And now from this, we'll probably just do normal Sudoku. The remaining digits in column 2 have to be 2 and 8. So we have a 2, 8, and this can't be 8 here because of the 8 in the column, or 8 in the row. So this is 2, this is 8, this is 2. Where is the 2 in column 1? Can't be here because of the 2 in the box. Same for this. And this can't be 2 because of the 2 in the row, so it must be here. Okay. Where is the 2 in column 9? Can't be here because of the 2 in the box. Can't be here because of the 2 in the box, and this is filled out, so this must be a 2. which makes this not 2. This is an 8. We should have 8 2s now. We do. We know where the last 2 has to be. It has to be here. 1s. We should probably, well, we know that's still a 1-4 pair. We don't know which one that is. 3s. We know where the last 3 is in this upper central box, so this is 3. That means in row 3, where's the 3? It must be here. In this box or row 4, where's the 3? Cannot be here because of 3 in the box, or here because of 3 in the box. And this must be a 1-4 pair, so this must be 3. What about 3s in column 6? These are filled out. These are filled out, and these can't be 3 because of the 3 in the box, so this must be a 3. That means we have, I think, 8 3s. Yep, we have 8 3s. We know where the last 3 has to be. It has to be here. So this is 3. 4s. 4s are also kind of scuffed right now. 5. Where is the 5 in this upper right-hand box? It cannot be here, and the rest are filled out, so it must be here. Because of the 5 in that row eliminates that 5. This 5 eliminates 5 here, so that's an 8. Where's the 5 in row 3? It must be here. Where is the 5 in column 7? Can't be here because of the 5 in the box. Can't be here because this is 1 modulo 3. Can't be here because of the 5 in the row, so it must be here. That means we have 8 5s. We know where the last 5 has to be. It has to be here. So that's all the 5s, 6s. This is the only remaining 6. That's the only remaining digit in the upper left-hand box. Therefore, this must be 6 here, because 6 eliminates that 6 here. This can't be 6 anymore, so 6 cannot has. In the lower right-hand box, 6 can't be here or here. It must be here. That gives us, 8 6s, so the rest, we know where the last 6 has to be. It has to be here, because it can't be here or here. So that's 6. 7s. 7s are, okay. We know that's a 7 because that's the last remaining digit in that box. Same here. That's a 7. And this must be a 7 because that's the last remaining digit in column 9. But we don't have any other differentiation for 7s. Okay, so that's 7s. We have 8s. Where is 8 in row 4? It has to be here. We have 8 8s now. So we know where the last 8 has to be. It has to be here. And then I think we have, no, we don't have all 9s. The 9 has to be here because that's the last remaining digit in the lower central box. That eliminates 9 from being here, so this must be a 9 here. What are we left with? 1 4s and 7s. This has to be a 4. This can't be 4, so this is 1. This is 4. This 1 eliminates 1 here, so it's 7. This is 1, which forces this to be a 7. And this to be 5. We missed that. We hope you enjoyed your stay with us, however brief it was. Come back sometime if you land in the Southern Triangle again. It's because Sagitta, right? Sagitta is, I believe, a constellation which is like the arrow. And so it's a Sagitta Speakeasy. Is, I guess, southern related. Because the arrow constellation is only seen from the southern hemisphere, I believe. I don't believe it's actually seen in the northern hemisphere. So that's why they're talking about southern. And since it's a speakeasy, they're acting like it's a bar. So, pretty cool. Oh, I guess, yeah, these are arrows, right? This is an arrow here. This is an arrow here. But I guess they could double as, like, tables or glasses. I'm not sure. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.